that maybe it starts real wide like this, but it gets a little bit more like this. That can be, or they can use oscillating, the same type thing, same type vocabulary. How we get this is when we have two functions put together. Now, it says here, identify the damping factor of f of x equals y equals x over 2 times sine x. Now, you notice right away that there are two functions here. One's trig, one's not. The trig is the sine x. The x over 2 is what's not a part of it. So as far as the damping factor is concerned, that is what's not trig. That's what's affecting the shape of the graph, like I was saying here. So if you're going to write the damping factor, I'll just abbreviate. The damping factor would be, you would say f of x equals, it's the part that's not a part of the trig, which is x over 2. It's a second function that is not included with the trig. That's your damping factor. That's already the answer. We saw that x over 2 is not a part of the trig, so that's the damping factor. So here's what I'm going to do. I'm going to go to the calculator, and we're going to take a look at this. So the first equation, or what they gave us, was that y equals x over 2 times sine x. And I'm going to graph that. And so here's the picture of this. Now you see how I was kind of saying the wave changes a little bit? Now it also says, then use the graphing calculator to sketch the graphs of f of x and negative f of x. Now this is what f of x is. So here's what I'll do, is I'll come back and I'm going to add equations. I don't know why my calculator does that sometimes. And the first one we had was x over 2. That's when it says f of x, it talks about the damping factor. Do the positive damping factor and also do the negative damping factor. So negative, there it is, of x over 2. So I did positive x over 2 and negative x over 2. Now I'm going to zoom out a little bit so you can see what's happening here. Now, isn't that kind of cool here? So this red line is F2, the blue is F1, the black is F3. Now I think this is a pretty neat little picture here, so I'm going to take a picture and move it over, back over here. So if we were going to describe the behavior of the graph, you can't describe the end behavior because it's going up and it's going down. But what you can do is see that it's increasingly, as you go out, it's approaching, it's going back and forth, and it's diverging, if you will. It's getting bigger and bigger. And as you get towards the center, it was converging at the origin 0. The damping factor are these two lines. It's the x over 2 and the opposite of it, which is negative x over 2. That's what finds the maximum of each one of these little oscillations in here. So there's their picture. I know it's kind of lousy compared to mine anyways. So let's try another one. So again, if you want to find the damping factor, you look at the function that is not a part of the trig. So if I come up here, this is not a part of the trig, the x squared. So the damping factor on this one is x squared. That's the first thing it asks me to find. Then it goes on, it says use your graphing calculator to sketch. So I'm going to go back over to the graphing calculator, and we're going to clear this real quick by going doc B. And the graph was x squared times, I think it was cosine of 3x or something like that. Let me go back. Yep, cosine of 3x. Okay, there's the graph. And we're saying there's a damping factor. This time it's x squared. Whoops. X squared. And we do the negative of it, which is negative x squared. All right, now I'm going to zoom out again, just like I did last time. And I'll show you this. I think it's getting almost too crazy, whoops, to see what's going on. The F2 is red. The blue is the F1. Well, it's not really moving with me. I don't know what's happening there. Well, you can just see it from this picture. And now, sorry, my calculator's not cooperating with me very quickly. Here it is. you can see that this time the maximums are lined up with the graph x squared up here and negative x squared going down here. That's how damping looks. It's pretty neat, actually. So there's their picture of it. And now here, I want you to identify